Hello, everyone, and welcome. Good morning. My name is Dr. Radwan Gansat. I'm one of the co-founders of MoroccoAI, and I'm very happy and excited to see you all participating and attending to the third edition of MoroccoAI conference. I have the pleasure of having with me today for the first keynote of today, Dr. Maha Gmira. So I hear, is there a technical issue maybe? Okay. So can you hear me? Can you just okay, let me just check.
So we kind of understand that they built some kind of a knowledge database.
Okay, all good. Just wanted to check because it's classic to have technical issues. So yeah, I have the pleasure to have with us Dr. Maha Gmira. She's an AI strategy expert at the United Nations. Let me share with you her biography. So Dr. Maha Gmira is an expert specializing in artificial intelligence, strategies and gender at the United Nations for Development. She's also she served as the head of the Artificial Intelligence Engineering School at Euromed, University of Fes. Her educational background includes a baccalaureate degree in engineering, a master's in mathematics, and a PhD in artificial intelligence from Polytechnique Montréal, Canada. Her doctoral studies were conducted in one of the world's leading centers of excellence in AI, especially under the Canada Excellence Chair in Data Science for Real-Time Decision-Making, Ivado, Cyril, Gerard, among others. So yeah, I have the pleasure to introduce Dr. Maha Gmira, and the floor is yours, Dr. Maha.
Thank you, Radwan. So let me just share my slides and let's start. Is all good?
Yes, perfect, thanks.
Okay. So let me start by this. I'm very happy today to be here among you to share with you work done in Africa in the context of smart manufacturing. And I want to thank MoroccoAI for this great initiative because it has been a long time that MoroccoAI is gathering AI community in Morocco and beyond. I have decided to present today joint work done with Abeba, my PhD students, to illustrate the importance of the regional cooperation, especially the South-South cooperation, when it comes to doing research in topics of common importance. Okay. In the context of smart manufacturing, we have tackled a problem which was solved by classical OR approaches, and we have used the deep reinforcement learning method, which is a quite...
Dear Dr. Maha, sorry to interrupt. Can you just move to first screen, please?
Which one?
Yeah, just do you see because we see
You mean the
slides.
full screen? Yes, yes.
Yeah,
yes.
yeah, please, yeah.
Of course.
Yes, perfect. Thanks.
Good. So it won't be long. Give me 2 minutes. I think there is something going on with the full screen.
Yeah, now we see all the slides again. Still not full screen.
Yeah, I know. Is that better? Because I think I can't do the both at the same time. I'm sharing. Okay.
Okay, we can continue then.
I can zoom in as much as I can.
Yes, yes, please. Yeah, perfect. Thanks.
Okay. My pleasure. So I was talking about the problem we decided to tackle. So in the context of smart manufacturing, the OR approaches have been used for decades, but not really deep. The learning approaches. And I'll conclude the presentation today by presenting the implementation results, so the performance of the proposed solution, and when compared to other algorithms and benchmark instances. So of course, for decades, heuristics, meta-heuristics, mathematical programming were very and still permanent tools to solve scheduling problems. But as the complexity and the scale of the problem increase, the solution starts to be unstable or even might lead to unacceptable computing overhead. And in smart manufacturing industries, we have huge amounts of data which are generated from heterogeneous sources. And we know a lot about IoT, sensors, RFID, networked machines, and so on. Inherent stochastic, when you add to this different sources of data, the stochastic processes are existing industrial processes. And the advancement of smart manufacturing, or what is called Industry 4.0 and industrial intelligence, have led to increased complexity, dynamics, uncertainty on the shop floor. And this behavior have paved the way for production scheduling challenges. So of course, nowadays, rule-based heuristics method for scheduling, planning, and production are commonly used, but their effectiveness is heavily dependent on expert domain expertise or on stochastic events, as I mentioned before. So decision-making performance cannot be assured, nor can the dynamic scheduling demand on the job shop production environment be met. And that's the big issue. So of course, we have the job shop scheduling problem have received increased interest from researchers, but the development of learning approaches to solve this problem has not been fully realized. So we decided to use deep reinforcement learning approach on dynamic job shop scheduling problem to minimize the make span. We designed the deep queue network, of course, which I will present later on, with state features, actions, and rewards. Job shop, for people from the OR community, I think they're very familiar with this problem. Job shop scheduling problem is a complex mathematical optimization problem whereby a specific number of machines must perform a set of operations on a particular number of jobs, and it is an NP-hard problem and concerns the distribution of scarce resources to a set of available jobs to optimize objective functions, such as the make span. And this is the objective we are targeting. But not only, you might also want to optimize the tardiness, the due date, the energy consumption, so forth and so on. So the job shop scheduling problem is a kind of sequencing that seeks to find the most effective machine assignment to various jobs comprising a set of operations, while keeping the problem constraints in mind. What are those constraints? The processing order, for example, or the machine sharing. So as I already said, this problem is non-deterministic polynomial hard, and it can be predictive if you decide to schedule offline, or reactive scheduling if you decide to control online. The offline scheduling assumes a complete knowledge of all the jobs to be processed and considers the real constraints available, which of course is far from being the reality. So what happens when you have random processing time, random job arrival, and machine failures? And we know that all those stochastic events are affecting the pre-scheduling effort. If you look back to the recent literature review, according to Kuna et al. 2021, scheduling problems can be summarized within 3 categories. Either this is a flow shop, job shop, or the open shop. So the flow shop, when all operations have a similar order of execution through the machine and all tasks are the same. This is quite easy. Job shop, unlike the flow shop, in job shop tasks, the tasks are different. Each task has its unique operation, and the operation orders of tasks are predefined and can be different from task to task. So we increase the complexity. And then the third category is the open shop. Operation execution order is not an issue, and operation can be executed at any time at any machine. So Of course, I'm putting some references of works which have been done previously with Abiba, with my PhD student. So the loading, application of reinforcement learning methods to job shop scheduling problem, of course, has numerous advantages, more flexibility than traditional heuristics, which I will show through the implementation results, the modeling capability of stochastic decisions, for example, random job arrival, the possibility of incrementally scheduling incoming jobs. And this is very important if you want to target real-time applications, and the ability to reuse the experience apart from a learning particular job shop. And the goal is to find to minimize the make span, to find the shortest make span. So let's first, if you don't mind, let's agree on some vocabulary. Suppose that you have a problem where you have n consecutively arriving jobs with j ranging from 1 to n, then they must be processed on m number of machines, where the set m varies from 1 to m, small m. Every job j is made up of predefined order operations, O, and the following assumptions and constraints were used for this work. Namely, the sequence of operations within the same job must comply. The operation should be processed without interruption. There are no priority constraints among the operations. Each machine handles only one operation. A job operation cannot be handled till the prior are finished, which makes sense, and the duration of the operations processing and the number of fractional machines is known from the start. Where again, to recall, the goal is to find the plan with the shortest make span. Now, those details are very important for the implementation of the DQ network. So the proportion of each machines, what you see here as the first equation, refers to the proportion of each machine's end time to the average of total machine end time at time t, which is calculated using the first equation, as you see, where c is a small constant to avoid the division by 0, which is resulting in a runtime error. The ratio of each machine's end time and the operating time of each job at machine K to the average of the total machine end time, ETA IK at time T, is defined in the second equation. The third equation concerns the ratio of each job's processing time to the required time to complete the job on the machine K, which is TCIK at time T. C, of course, still a small constant. And the input features used as input to the job shop scheduling problem, agents are EAJ at time T, ETAIK at time T, and TCIK at time T. As a result, the input features are defined using the last equation. Okay. So as you might see in this figure, the study highlights using 5 matrices. This is on your complete left in the job shop scheduling environment to demonstrate the state of the job shop problem, which consists on the process time matrix, the processing order matrix, the start time matrix, and the end time matrix, and finally the scheduled plan metrics. So 5 different matrices as the state. You have to add to this 3 feature vectors are designed to be used as an input to the DQN scheduling agent. At the beginning, the state of the network is initialized, and deep learning updates are performed based on the loss function. And as a result, in the proposed method, the loss function involves the square error of the target and predicted Q value. What we are proposing today has 2 basic components. You have the scheduling agent interaction with the job shop environment and the DQN training component. Now let's move on from in this figure to the left. The job shop environment is characterized as a set of jobs with a processing scheduled plan processing order, start and end time of the scheduled job, and the processing time. And then the deep queue network scheduling agent is observing the job shop environment state change and then perform an action to pick an operation from the currently idle machine to process job continuously based on the processing order and minimize the maximum completion time, which is of course our make span. Then after acting, the deep queue network scheduling agent collects the reward from the make span provided by the job shop environment, initiating the next time step. So this is how we model the deep queue network. Then, of course, maybe you are asking yourself, what is the DQN policy? The DQN policy is updated by randomly selecting minimum batches from the reply memory. Initially, the DQN agent communicates with the job shop environment by learning from mistakes after the DQN agent has learned the best policy, which is going to be referred by P. The trained model can be used to perform real-time scheduling, and the DQN agent will face unknown job shop environment condition. Adaptive scheduling can be achieved by updating continuously the DQN agent policy. So of course, the primary objective of the training is to lessen the make span, to minimize it. The training is conducted using the DQN exploration and exploitation approach, the overall process of the training. So the concerns the implementation, I'm going to give few details, but of course of the hyperparameters, but you can refer to the paper if you want to see more details. So the feature vector phi and the y parameter theta of the DNN are initially chosen at random. The DNN configuration used in the study consists of input with 3 input features, 4 hidden units, 512 nodes, 1 hidden unit, 256 nodes, and another 64 nodes. The nodes of the output layer is constant and equivalent to the number of jobs. The number of iterations is from 36 to 100, depending on the size of the instances. Of course, more details, numerical details about the parameter and the hyperparameter can be easily found in the paper. At the start of the training, what is important, I think, to highlight today for the conference is the whole training process. So at the start of the training, the scheduling agents acts based on the present state, which basically consists on evaluating the job to be handled, while the exploration strategy provisionally keeps track of the new operation order. And when a new job is planned, the state changes to the flowing state, and the environment instantly rewards the DQN agent. And when the exploration approach contains a specific number of scheduling orders, the order is chosen at random and trimmed to a specific length. The training process of the DQN scheduling solution and the make span curve, as you can see here in the next slide. So this is the result, and then I'll show some numerical results. So you can see the curve on the left, the 4 curves on the left. On the other hand, you have the 2 figures on the right showing the scheduling solution. So the agent chooses actions at random to store in the reply buffer. After a certain period of gathering good experiments, you see that the optimization effects of the learning stage starts to emerge. And after some training, some training is completed to a certain extent, the make span of jobs no longer significantly decreases, but it varies seamlessly, indicating that the agent has gained a stable policy. And this is what we were looking for. From a numerical perspective, the scheduling performance increases with an average of almost 70%, a little worse than that what the proximal policy optimization into of instances 10 by 10 was doing. However, the average performance on the instances 6 by 6 and 10 by 5 is improved by almost 80% and 1.81% from heuristics and the proximal policy optimization, respectively. So to end up with few takeaways, the proposed method has the age that once trained, it can be used in real time. And this is what we were trying on our fourth paper, to acquire scheduling plans, ensuring scheduling accuracy, improving scheduling efficiency. Developing the appropriate network architecture was necessitating numerous design decisions, which need, of course, further investigation, that's for sure. Additionally, the reward function has a considerable impact on learning, and we tried several reward functions throughout our investigation before finding the function that worked. And my PhD student can of course testimony. And finally, the input of the DNN is a fixed size input features. However, when the number of instances is growing, the model must augment and retrain to accommodate the new job shop scenarios. So yes, work has been done, but we believe that still improvements can be done, and this is what we're still working on.
Thank you very much, Dr. Maha Gmira, for this excellent and very informative presentation.
My pleasure.
Time was respected. Thank you very much. And now time for questions. So I did receive many questions. Some of them are very specific to the technicalities of your work, and some of them are very general. Let me start maybe by the technical ones. So the first one is the following. So RL, I think it's reinforcement learning, and deep QNets could suffer from the curse of dimensionality because of the exploitation mechanism. How can we tackle that problem in the context of your application?
That's a very good question. And actually, not only are all approaches are suffering from the curve of the dimensionality, but also some classical OR approaches. And the answer is that there is no one solution which gonna solve all the problem, one size fits all. But one way to do so is diversification. So each time you try to diverse your set of solutions to go away from the conversions, and then you start to explore better in other ways. And it depends hugely on the problem you're tackling. Diversification techniques are very different. And it depends on the problem. When you are using reinforcement learning approaches, we were using something very similar to taboo search, for example. We diversify each time we start to find the same solution each time. We diversify through starting from a new solution. So we even go back 10, sometimes even 20 solutions back, and we retrain again to diversify. So that would be one way to do so.
Okay, yeah, that's clear. The next question is the following. The person who asked, thanks you very much for the great presentation. And the question is the following: how frequently does the model need to be retrained in a real industrial setting? Is the policy retrained each day from scratch, depending on the day's workload priority, or do you carry over the last trained policy?
Very, very relevant questions. And I feel that people are very concerned about the topic. So to be really honest, this was a trial to be implemented in the context of Industry 4.0. So in the region of Fas Meknes, and I think this is one of the first initiatives in Africa. There is an ongoing project with the region and the US Challenge Corporation, which aims to build a whole Industry 4.0 ecosystem. So this project was done with the African Union ASRIC and the region of Fas Meknes to try to implement real-time algorithms for digital twins, for real-time decision-making on the shop floor. So of course, when you know that, that's why I start with this with this introduction, when you know that the algorithm you are designing is for a real-time application, you can't retrain as you want and as much as you can. So you, of course, you have to set a threshold between advantage and computing time. So basically, this is not a step we achieved right to now, to be honest. This is something now we are conducting. We have 3 papers after that one, trying to improve each time our methodology and few technical aspects. And we, in the context of a real-time application or a real application, not necessarily real-time, it might be near real-time. We can't offer to retrain constantly, maybe a day or based on events. That was what we were thinking about after retraining as soon as we have events coming on the shop floor. But very relevant question.
Yeah, and I thank everyone who's asking questions. Yeah, please continue asking questions. So I do have now I have like an exercise to do, because I do have a lot of questions which are very general. Maybe I'll leave them to the end. And I do have 2 questions about your position, your current position. So people are maybe curious to know more about your job at the United States. You working as an AI strategist in the United Nations, sorry. Yeah, so can you tell us more about maybe your day-to-day job?
Yeah, that's far from, you know, as I told you, the one at the beginning, so what maybe people are, they were not aware of. So before starting the conference, I was telling Radwan that this is by far the first it has been a year we didn't present our technical work. And I've been, of course, presenting, sensitizing toward using AI, generative AI. And I was super happy to tackle technical questions and to be challenged. So unfortunately, it didn't last long. So now we turned.
Yeah, I still have other questions. Don't worry about that.
I have time and energy to answer questions, Radwan, don't worry. So concerning my current position, so it's a current position within the United Nations Development Program, the UNDP. And it concerns advising on the strategies of artificial intelligence, but also the question of the gender in education at general, but more specifically in higher education, research, scientific research, and innovation. So basically, as you might understand, generative AI and AR is reshaping, AI in general is reshaping the education. So the focus is how to use it as a tool, but also, of course, to educate people, but also how to teach AI and the limitations of AI to students. And that's the big issue. So there are 2 main components in what I am doing: how to use it as a tool to leverage education and the assignment evaluations, in general, the evaluation process for the teacher, but also for the trainer, the trainee, and the whole ecosystem. And also what are the best practices to teach AI today when we know that it's evolving very fast. So that's my job today, but I'm doing also research. I'm still a researcher in my previous lab in Canada. So yes, and I think it's very essential for my current position to keep going on research.
Of course.
Yeah. But thanks for the question.
Yeah, sure. And yeah, the thanks goes to the participants who are asking really a lot of questions. So I'm really trying to respect time and to ask you the more relevant ones. So yeah, let's go back to the reinforcement learning. This is a very general and very interesting question, actually. So the question is, we see ups and downs in the interest towards RL, reinforcement learning. Do you know the reasons? For example, reinforcement learning was a very hot topic when AlphaGo was developed.
I'm sorry, I was reading questions, Radwan. Please,
yeah,
can you
sure, no problem. I can tell it again. So yeah, this is a question, a general one. So the question is, we see ups and downs in the interest towards RL. Do you know the reasons? And for example, RL was a very hot topic when AlphaGo was developed.
Mm,
Yeah, probably about research, maybe. Research interest towards RL.
yeah, honestly, when I was doing my PhD, we were the hot topic at that time, and it's not that time ago. And where the hot topic was how to combine OR techniques to improve learning architectures or learning processes. That was the hot topic. And that was in 2018, 2017, until 2020. And the people in the lab of Yoshia's Benjo Mila, but also Andreas Laudi's lab within the Chaire d'Excellence du Canada. So that was the main interest, how to use, because we do believe that those two communities, or our community and the AI community, were not bridged. And there was, and I do believe that still today, there is much to gain when you start to bridge between those communities. And I can make, of course, I can send you some links, some papers, very relevant papers, mainly the one with Giulia Zarpelloni, Yoshia Bencho, and Andrea Laudi. Cut and bounce for learning. And this is an amazing paper. Then I know that by the end of my PhD, some people were hugely interested in reinforcement learning approaches, but of course, reinforcement learning is not as the use of deep or machine learning, because you have to have a very specific problem where general data is scarce, and you have the process to learn is not well known neither. So that's the point. You have to have specific conditions which gonna make the reinforcement learning the right and the best approach. And of course, doing reinforcement learning for at least 4 or 5 years, I know that it's neither an easy approach for the agent, for the reward function, for the agent environment. So it's a complex problem, which is not suitable but I don't know exactly if really, because sometimes in some labs research is going, but not really for the common public. So people, they don't know that it's a current ongoing research until it comes to the common public. So I don't have Radwan and black or white answer, but I know that it is a very interesting approach for very specific problems. Maybe that machine and deep learning are used for various topics, for various problems, and which makes people maybe like those two techniques much, or being interested in those two techniques much than reinforcement learning.
Yeah, thank you. Excellent answer. You mentioned some papers, some resources. We can actually maybe share them with the attendees
Sure.
later. And there was also a question, a person actually who thanked you very much for the interesting presentation, and they said that they have available data that could be interest for your problem. So yeah, I'll make you maybe in contact with that person for more details. So yeah, there is a related question, again, general, very open question about the recent trends or the new trends of RL, of reinforcement learning. If you can maybe say some words about that, like the latest works, how do you see the future of the field also?
That's a very interesting question. I'm sorry, I just realized that I didn't turn on my camera after the question, after the presentation. So that's a very interesting question. And as you, Radwan, thank you. You read my bio before. So as people know, I've been living abroad for many years and coming back to Africa, to Morocco, more specifically 3 years ago. I'm now concerned with trends, with African trends, because I do believe that research must be sovereign, must answer priorities, national and regional priorities. So for today, so I'll answer from this perspective. And of course, if If people want more details about the American perspective, I can of course answer that too. So from the African today perspective, three main challenges. So reinforcement learning for renewable energies, very important. And not important because it is important, it is of course, but because it gives very interesting results. Then you have reinforcement learning for agriculture, precision farming. So there is a very interesting project with the African Union, but also with the Europe Horizon, which is going on with the participation of more than 10 partners between Europe and Africa. And the objective is to use reinforcement learning to take the best decisions for the farmer when collecting data from a kit within the farmer and sharing open data structure for the partners in Africa. And then you have, so I mentioned farming, agriculture, and renewable energies, and of course, what I've been presenting today, so smart manufacturing, industrialization in general.
Thank you very much. This is an excellent answer. And actually in MoroccoAI, we are always interested in the Moroccan African point of view though. So very much like this answer. So yeah, another question more related to this time oral, but in particular for education, in the context of education. So this is again a very general question. So what are your thoughts regarding applying AI and RL in particular in the context of education, upscaling and downscaling, and downscaling, upskilling and downscaling? Yeah, again, yeah, very large question. Yeah, that could be done in a whole webinar just on its own. Yeah, maybe just few words because I know time is running out.
I'm smiling, I'm laughing because I think I'm happy actually that people are interested in what we are doing. And of course, education, I'm just realizing that it's a bit far away from Industry 4.0, it's manufacturing and DeepQ network, but it's okay. Thank you very much for this answer, this question, much appreciated, because it reveals that people finally are just very interested in what AI can bring to the education system. So let's talk about AI in general, because I think that for the education specifically, generative AI can bring more than reinforcement learning. So let's talk about AI. So today, of course, as I said, there are two different parts. You can use AI to leverage education, but you have to know as an education system, as a country, as a government, what are the best way to teach AI, because not everything is you can't take everything from AI and teach students at different ages. So today we, of course, generative AI can help generating assessments, doing adaptive learning, when you know that today Morocco is oriented toward teaching at the right level. So how, for example, for a teacher in a class, in a given class with 30 students with different levels, for French, for example, or mathematics, how to deal with those stages, with those levels. So one way is to use, of course, generative AI or adaptive learning, more specifically adaptive learning, to generate assessments for specific levels and to have this fair evaluation, meaning that you cannot evaluate all the students to achieve the same objective, but just to measure the improvement of each student. And that's a complex challenge. And this is what other countries are calling fair evaluation. You have also, of course, augmented, but this is not really AI, augmented virtual reality to visualize more some aspects, dimensions of learning topics. What else? When you know that in universities, for example, you have thousands and thousands of copies, you can easily use computer vision to solve this issue and to save professors' time. I mean, look, this is a huge This is a huge topic, very important, but we can talk about it for a day. But what for sure, Radwan, is I do believe that today we cannot go beyond this revolution. And
Of
for
course.
for many reasons, today we are quite prepared for this revolution. We just have to envision the AI collaboration with the human, and of course to set guidelines and to set guardrails for the use of AI in terms of governance, in terms of regulations, and in terms of law and strategy.
Okay, thank you very much for this complete answer. So, I did receive other questions, other similar questions like applications of RL for other fields. So yeah, maybe let's just try to wrap up because time also is running out. And sorry for all the people. I'm trying to ask as much questions as I can, but yes, time is limited. So maybe last word from you, Dr. Maha Gmira, to the MoroccoAI community. The floor is yours now.
Thank you, Radwan. So I want to thank, of course, all the organizing committee, the speakers which are going to come after. I'll be very happy to listen to them. And of course, to MoroccoAI, which as some people might know, or everyone might know, because so this is a beautiful community which gains nothing apart gathering people around specific AI topics. As you said, Radwan, and this is very true. Moroccan concerns AI. So I was very happy to participate today. And if you don't mind, I will answer questions, of course. You can just send me the questions and I'll take time this afternoon to answer all of them. I was very happy to be here today with you.
Thank you very much, Dr. Maha Gmira, and thanks again for accepting our invitation. So yeah, thanks to the attendees for your participation, and yes, see you for the next keynote speaker, who is Karim Amour, in a few minutes. And thank you again, Dr. Maha Gmira. It was a pleasure hosting you with us in the 10th edition of the conference, and see you very soon.
Yes, thank you, Ridwan. Good luck. Bye.
Thank you. Bye-bye.